All right, today we're going to talk about a really fascinating new concept for AI. It's an idea that just flips the script on the current bigger is always better race that's happening right now. See, instead of just throwing more data and more computing power at the problem, this vision uses some, well, surprisingly simple principles to build something that's lean, totally private, and maybe, just maybe, universally intelligent. Okay, let's get into it. So here's how we're going to break this down. First, we'll take a look at the problems with the AI models we have today. Then we're going to dive into this simple, kind of brilliant mathematical philosophy that's at the heart of this whole thing. After that, we'll see how that philosophy actually turns into a real architecture, introduce a pretty radical new way to represent information. And then, at the end, we'll pull it all together to see what the promise of this approach really is. Okay, so before we can really get into this new idea, we've got to talk about the problems it's trying to solve. What are the challenges we're up against with the current generation of AI? The AI models we're all using today, they're built on a scale that is just almost impossible to wrap your head around. We're talking about training them on trillions of tokens. That's bits of text, images, and data scraped from all over the internet. Now, this massive training process is exactly what makes them so powerful, but it also creates some really serious problems. And that brings us to the real heart of the matter. The whole industry, it seems, is locked in this race to build the biggest, most massive model possible. But is that really the only way forward? I mean, maybe this constant obsession with scale is making us ignore some really fundamental issues. So, what's the fallout from this race to be the biggest? Well, for starters, these massive models demand an insane amount of computing power. That costs a fortune, and yep, it has a real environmental impact. But maybe even more importantly, they often need our personal data to work well, which creates huge privacy risks. And honestly, for all their power, they still kind of struggle with deep, genuine personalization. This is why we so desperately need a new way of thinking. All right, let's shift gears and talk about the core philosophy behind this new vision. And what's so cool about this is that it's not based on some crazy new algorithm, but on a concept. Well, a concept we all learned back in elementary school math class. This quote just says it all, doesn't it? The goal here isn't to add more complexity. It's to strip it all away. It's about finding a foundation to build on that is so radically simple, it's almost, well, stupidly simple. So, this whole philosophy is built on two things you definitely remember, HCF and LCM. Now, think about it this way. HCF, the highest common factor, is used to find the absolute core of a question, the shared essential thing that lots of people are asking about. Then, LCM, the least common multiple, is used to build the simplest, most efficient answer that is still perfectly personalized for you. One finds the common problem, the other finds the common solution. And this just perfectly illustrates that balance, right? The system uses HCF to understand the collective what, the greatest common thread of the question. Then it uses LCM to deliver the individual how, the first sync-up point for an answer. One looks for common ground on the way in, the other finds common ground for the way out. They absolutely have to work in sync. Okay, so a philosophy is great, but how do you actually build something with it? Let's get practical and see how you can take this idea and turn it into a real architecture. Exactly. It's a fantastic question. How does this whole HCF/LCM concept go from just a thought experiment to, actual code and servers? Well, the answer is in this really clever split between what happens on your device and what happens out in the cloud. All right, here's the flow, step by step. Your request, whatever it is, first goes to this small personal thing called an adapter that lives right on your phone or your computer. This adapter then talks to a really lean, memory-free core model in the cloud, which uses shared community weights for its general knowledge. Then, the core model sends back this abstract encrypted response, and your personal adapter is the only thing in the world that can decrypt it and tailor it just for you. And this is the absolute game changer for privacy, seriously. Because all the personalization, all the decryption, it all happens inside that adapter, on your device. Your sensitive data never, ever has to leave. The big central model in the cloud, it doesn't even know who you are. It's just dealing with abstract questions and answers. And now we get to what is maybe the most creative, most mind-bending part of this whole concept. To make this lean model truly powerful and universal, it needs a totally new way to understand the world. It needs a new kind of token. The core idea here is to create a universal token that's based on frequencies. So instead of having separate models for text and images and audio, this system would convert everything, and I mean everything, into a single common language. Just imagine the Mona Lisa, the opening notes of Beethoven's Fifth, and the sentence "Hello World" all being translated into their own unique frequency signatures. The core model wouldn't see a picture or hear sound. It would just see a specific wave pattern. It's a way for it to understand literally everything in the same native language. Wild, right? So, how in the world do you build a token that rich? Well, the idea proposes 3 layers. The first layer is an analogy to geography. This sets the base communication pattern. So, for example, a direct, to-the-point question might be encoded with a frequency that's like the plains, straight and efficient. A more layered, complex question might get a mountain signature, winding and nuanced. It's a way to embed the style of the communication right into the data itself. Then, on top of that, you add a second layer, temperature. This adds even more nuance. The idea here is that communication styles can be mapped to climates. For instance, a bold, assertive statement could be encoded with an offensive or expansive frequency, kind of like heat radiating outwards. A more reserved query might get a defensive or compact pattern, like conserving warmth in the cold. It's all about capturing the energy of the communication. And finally, you have the third layer, time zone. This adds that dynamic, ever-changing context. I mean, we all know we communicate differently at 3 in the morning than we do at 3 in the afternoon, right? Well, this layer lets the frequency signature shift based on the time of day, capturing the natural rhythm and context of human interaction. You put these 3 layers together, and you get an incredibly rich, multidimensional token from any type of data you can imagine. So, let's put it all together. When you combine the HCF/LCM philosophy, the adapter architecture, and this wild universal frequency token, what's the ultimate promise? What could this kind of lean AI actually do? Well, what you get is a whole host of potential breakthroughs. It's radically efficient, which slashes the massive costs of today's models. It has privacy built in from the ground up by design. It could achieve true generality, able to process any data type through one single system. It would allow for incredibly deep personalization through that on-device adapter. And by sharing the compute and the weights, it could actually democratize AI, making it accessible for everyone, not just a few giant companies. At the end of the day, the suggestion here is pretty profound. It's this: maybe the path to artificial general intelligence, to that superintelligence we're all talking about, isn't about brute force and trillions of tokens. Maybe, just maybe, it's through a more elegant, efficient, and nature-inspired design like this one. And that really leaves us with one final thought to chew on. We are so focused on scale and on power, but this whole concept asks us to think about a different goal entirely. What if the future of AI isn't about building the biggest brain, but about creating the most elegant and harmonious system?